In this video, we will cover Chapter 6, Benzene, and its derivatives. For Subtopic 6.2, Nomenclature of Benzene, and its derivatives. The learning outcomes for 6.2, Nomenclature of Benzene, and its derivatives, are: first, draw structures, and name benzene derivatives, according to the IUPAC nomenclature for monosubstituted benzenes, disubstituted benzenes, tri- and tetrasubstituted benzenes. Secondly, to apply IUPAC rules, to name compounds with C6H5, phenyl, or C6H5CH2, benzyl, as substituents. Let's take a look for naming monosubstituted benzene. Benzene with one substituent.
Benzene derivatives containing one functional group attached to the aromatic ring are referred to as monosubstituted benzenes. In these compounds, benzene is the parent name, and the substituent is indicated simply by a prefix. Ethylbenzene, bromobenzene, and nitrobenzene are examples of such names. No numbers are needed, since all the ring carbon atoms are equivalent. Many monosubstituted benzenes have common names too. They are so widespread that the International Union of Pure and Applied Chemistry retained them in the nomenclature system as parent names. Toluene, styrene, phenol, aniline, benzoic acid, and benzaldehyde are examples of such names.
As stated before, based on the IUPAC rules, it allows some common names to be retained, such as toluene, phenol, aniline, benzoic acid, benzaldehyde, and also acetophenone. For examples, the first structure has isopropyl as substituent. Therefore, the name is isopropylbenzene. For the second structure, it contained butane as substituent, which become butyl. Thus, the name is butylbenzene. Now, let's take a look for benzene with two substituents, and how to naming them.
Since there are 6 carbon atoms in the benzene ring, desubstituted benzenes can form 3 different structural isomers. These compounds can be named either by giving the numbers of the carbon atoms to which the substituents are attached, or by using the ortho, meta, and para locators. Ortho, from the Greek meaning straight, means a 1,2 desubstituted benzene, with the substituents on adjacent carbon atoms. Meta, from the Greek meaning after, indicates a 1,3 derivative, and para, Greek beyond, a 1,4 derivative. Ortho, meta, and para locators are normally abbreviated to O, M, and P, respectively. 1,2-dibromobenzene, or ortho-dibromobenzene, and 1-ethyl-3-nitrobenzene, or meta-ethyl-nitrobenzene, are examples of disubstituted benzenes named in this way. When one of the substituents imparts a special parent name to the aromatic compound, as for example in the case of toluene, only the position of the second substituent is given. 4-nitrotoluene, or para-nitrotoluene, is the proper name for the compound shown on the screen. Other examples include 3-nitroaniline, or meta-nitroaniline, 2-bromophenol, or ortho-bromophenol, and 4-hydroxybenzaldehyde, para-hydroxybenzaldehyde. Note that the order of appearance of substituents in the name is alphabetical, and that the smallest possible numbers are used to indicate their positions.
Carbon atom, which bearing the substituent that define the new parent name, is numbered as carbon 1, which based on priority, the highest is carboxylic acid, followed by esters, aldehyde, ketones. For this structure, the hydroxyl group will numbered as carbon 1, which gives new parent name, phenol. while the amine substituent becomes carbon 4-amino. Thus, the name is 4-aminophenol, or p-aminophenol. For examples, the first structure contains NO2 group and chlorine atom as substituents. Cl substituents becomes the first carbon, due to the alphabetical order, which gives the name of the structure, M-chloronitrobenzene, or 1-chloro-3-nitrobenzene. The second structure contains carbonyl group and bromine atom as substituents. Carbonyl group, C double bond O, becomes the first carbon, as it give new parent name, benzaldehyde, which gives the name of the structure, p-bromobenzaldehyde, or 4-bromobenzaldehyde. Now, let's take a look at tri- and tetrasubstituted benzene.
When 3 or more substituents are attached to the benzene ring, they're located by their numerals. If one of the substituents gives the parent name, then the number 1 is attributed to the carbon atom to which that substituent is attached, and then the other substituents are given numerals accordingly. If none of the substituents imparts a parent name, the substituents are listed in alphabetical order, located in such a way as to give the minimum sum of numerals, and the parent name benzene is added at the end.
Example, in this structure, there are 3 identical bromine atoms as substituents. To naming it, we must give substituent with lowest possible number. Therefore, the correct name for this structure is 1,2,4-tribromobenzene, not 1,2,5-tribromobenzene. Another examples. Substituents that give a new parent name will become carbon 1. Next, give the other substituent lowest possible number. Therefore, the name of first structure is 2-bromo-5-chloro-toluene, while the second structure is 3,5-dihydroxy-benzoic acid. The last example. Can you determine the name? The answer is 1-bromo-3-chloro-2-ethyl-5-isopropyl benzene. The next part of naming, let's take a look if benzene become the substituent.
Such a substituent is called a phenyl substituent, and is often abbreviated to pH. For example, hexyl benzene can be named 1-phenylhexane, and abbreviated to C6H13PH. This method for naming benzene derivatives is particularly useful when naming molecules with a complex substituent structure attached to an aromatic ring. We can see that the substituent on the benzene ring has a complex structure, and that therefore the compound should be named as a derivative of 3-pentamine. Numbering from left to right gives a smaller sum of numerals than numbering in the opposite direction. The amino group comes before the phenyl substituent in alphabetical order. Therefore, the name of the compound is 2-phenyl-3-pentamine. You perhaps notice some inconsistency in the naming of a substituent derived from benzene as a phenyl substituent. You just need to remember that it is not so, and to avoid confusion, learn by heart the difference between these two substituents.
As stated before, when benzene becomes a substituent, it will be a phenyl group, with pH abbreviation. It also can be a benzyl group, with C6H5CH2. Example. When the alkyl substituent is larger than the ring, more than 6 carbon, the benzene will become a substituent, a phenyl, substituted alkane. 2-phenyl-heptane. In second structure, if the chain contain important functional group, the benzene also considered as phenyl substituent. Thus, become 2-methyl-3-phenyl-butanol. Can you guess the correct name for this structure? The last structure is an example for benzyl group. chloromethylbenzene, or benzyl chloride. That's all for 6.2, Nomenclature of benzene, and its derivatives. Thank you for watching.